Ukraine, 1986. During the reactor 4 explosion, tons of highly radioactive debris were scattered across the Chernobyl nuclear power plant site. In many places, levels of radiation were beyond what a human being could withstand. So they needed machines that later became known as Chernobyl robots. Many of you know the infamous Joker robot, a replica of which you could see in the HBO Chernobyl miniseries. But the true story is much more dramatic. We got unique documents that give a detailed insight into those hot days. So today we'll look into the history of Chernobyl robotic systems. After our previous episode, many of you liked our idea to build a full-sized replica of this Chernobyl Spetsatom Scout robot. So, the research work is already ongoing, and with the help of some of you we also got some components. You can become a part of this project by joining us on our Patreon page, where we will post all updates. Link is in the description below. When the disaster happened, many believed that somewhere in the hidden hangars there are special machines ready to deal with all that. But what was next proved that mostly it was just empty communist propaganda, and many things in reality had to be created straight in the disaster zone. And to understand why some of those machines failed and others succeeded, it's necessary to take a look at the conditions they had to work in. The debris scattered across the power plant site created very diverse conditions. Radiation levels varied very much, but next to the damaged unit they reached deadly hundreds of roentgens per hour. The key problem was that previously well-known territory became in fact a completely unexplored terrain with a lot of hidden hazards yet to be discovered. The damaged core continued to burn for a few more days, ejecting the radioactive aerosols, making the contamination worse every hour. Below, a lava-like mixture of melted nuclear fuel, concrete and metal has been spreading across the bottom levels, forming large ceramic-like elephant feet. There is a very descriptive fact which may be very hard to believe for you. One of the most effective robotic mechanisms that helped to explore the rooms of Unit 4 during the earliest period was a toy tank, bought by one technician in a toy shop in Kiev. He attached it to a camera, also added a radiation detector and strapped a few dosimeters with the regular duct tape. By the way, we less more identified its components, so if you wish us to rebuild it as well, just let us know in the comments. The internals of the damaged facilities were only a half of the problem, because even more scary, the situation looked on the roofs. A significant amount of graphite and pieces of fuel components have been thrown there, and in many cases all that submerged into the bitumen that became pretty hot during the fire on the night of the disaster. And those graphite blocks actually weigh a lot. Here is original map of roofs that was created step by step starting from July 8, 1986. At that point, some primitive machines already have been working inside the buildings and below the damaged reactor. But as for roofs, only airborne measurements and photography have been done at that point. There were defined zones marked with letters from A to T. Surveys started in July, some have been made manually, some using the robots we'll talk today about. And what was discovered there was truly a nightmare, because the conditions varied from tens of roentgens per hour in the Zone B to more than 10,000 per hour in the Zone M, located under the iconic chimney. Those stars and flags mark exceptionally radioactive spots. Those spots on the roof, however, were yet not discovered when the ultimate task was placed: to design and to build an isolation structure over the damaged unit. The work started on the surface to get more information and to clean the place for this one-of-a-kind construction site, but first just to get closer to the nuclear beast that went out of control. Initially, those works were managed by the governmental task force. Later, robotics became a realm of the Spetsatom Special Enterprise based in the city of Pripyat. In hangars, which are now next to the famous claw, they had a test polygons for their machines. And we had a luck to get some first-hand stories about that. Once more, we got a massive help from Michael Bukov, a former engineer of Spetsatom, who shared a lot of technical details. And a couple of weeks ago we had a meeting with Vyacheslav Kushmякov, a scientist from the Kyiv Institute of Automation who designed one of the very first Chernobyl machines. Back in 1986, this man developed a remote control system for a T180M bulldozer. Originally it was intended for metallurgy, to clean smelters when they are still too hot. But in May 1986 some quick solutions were needed, so the governmental task force gave the order to adapt this amazing machine for harsh radiation. So in a short time T180M was transported to the test polygon in the Kyiv region and soon started its hard work at the power plant site. Mr. Kushmякov has shown us the original control unit and explained in detail how exactly he would control this bulldozer. You can listen to his explanation in the full version of this video you can find in our Patreon page. And the actual control panel you can see in the Museum of Chernobyl in Kyiv. There were many other remote control bulldozers used for the same tasks, but perhaps one of the most unusual examples was the Japanese Komatsu D155W. This machine was originally designed for underwater works, so it naturally operated unmanned, which was a great advantage. Unfortunately, it appeared to be not very stable in those harsh conditions, so it quickly went broken. Up to the present day you can find remains of it. It stands in Pripyat, at the far corner of Jupiter factory where Spetsatom was based in the past. In the same period of time, the Research Institute of Transport Machines, also known as VNI Transmash, received another task: to build a sturdy and powerful robotic complex. So in just 44 days they created one-of-a-kind system called Clean One, which consisted of two machines connected with the radio channel. The first, coded Object 032, was a nearly 50-ton heavy remotely controlled IMER-2 engineering vehicle. Its engine and traction have been modified to better withstand radioactive dust, which later appeared to be a general burst problem of many IMER machines. The second was an airtight command vehicle, coded Object 033. It was built based on T-72 tank chassis, additionally protected with lead. It had control equipment and a CCTV system that allowed it to get the live image from the cameras installed on the IMER at a 200-meter distance. Inside there were places for two people, a driver and an operator. This robotic complex was very successful because it could clean more than 11,000 square meters. Eventually, when it got too contaminated, it was transported to the Burakivka disposal site where the robotic IMER was buried in a trench. But the command vehicle is still standing at the overground storage. Well, it's pretty tightly surrounded by other vehicles, so it's really hard to come closer to it, but here is a picture I made many years ago. Unfortunately, not all machines that worked on the surface were so successful. Some of them started to have malfunctions really quickly. For instance, exactly this fate had this very underground mining loader, which you can see in the movie Belle of Chernobyl by Roland Sergeyenko. Honestly, I feel really much for that operator who obviously had serious reasons to get out from there as fast as possible. But the rooftops of the power plant became not a smaller challenge for any kind of machines. This thing is RR-1 Scout robot. This and its later modifications were simple remotely controlled mechanisms equipped with a camera and a set of detectors. They were designed and produced by the Russian Institute of Robotics and Technical Cybernetics in just a couple of weeks, and first, in June 1986, they explored the turbine hall of Unit 3 and the pool below the Unit 4. Later, they were deployed to the roof of the zones B and K, where they were used to measure radiation. Well, according to reports, those readings appeared to be really inaccurate, and because of their poor design, often these robots fell aside, so people had to run and place them back. Technicians who helped those robots received 100 röntgens of the dose in total. So eventually mechanisms made by this institute were no longer used in those zones, and the remaining contamination maps were built manually, because actually that would require significantly lower exposure for people. If you ever have been to the town of Chernobyl, you likely have seen this exhibition of some robotic equipment. For example, this Beloyarets robot was the very first designed and used for the decontamination of roofs. That happened in June 1986. It was created very fast with little information provided to its designers, and eventually it was made from what was available around. For instance, its chassis came from an airport cart. In total, Beloyarets worked at the Chernobyl Nuclear Power Plant for about 1 month, mostly in the Zone K, the rooftop of the reactor hall of the Unit 3, until it got a malfunction of its steering rod. Well, after repair, it was no longer used due to numerous reasons. In the beginning of July, Institute of Robotics and Technical Cybernetics brings to the power plant TR-A1 robot. Well, this one had a bucket-like scoop, a scanning television camera and a 100-meter-long control cable. TR-A1 was used on the roof of the aerator compartment, and later it was replaced with TR-A2, which was already equipped with a frame for easier transporting by helicopter. But reports show that their questionable design caused more problems than any positive effects, because all in all, those mechanisms removed maybe 400 kilograms of debris in total, but they were very slow, and eventually, to clean the aerator roof, a manned lead-line tractor was used. That work, together with all attempts to help those robots during their malfunctions, ended in a overexposing of 80 people that no longer could work on site. Well, those machines worked at least somehow, but unfortunately some didn't work at all. The infamous German Joker robot is a good example. Its official name was MF2, and it was designed originally for mine clearance. There were high hopes for this robot, so its work area was the deadliest Zone M, where levels exceeded 10,000 röntgens per hour. Using the demag crane located near the reactor auxiliary system building in the Zone N, a ramp has been placed, and Joker was deployed to the Zone M using that ramp. Well, it worked just a little, radiation burned its electronic brain, and at some point it started to move by itself. That way it stuck, becoming an annoying obstacle on the way. There were a few attempts to revive it, eventually it was just dropped down and removed. Therefore it's possible to notice that from one side there is some damage. For some period of time it was stored in Pripyat along with other disused robots, and nowadays Joker stands at open-air storage at the Burakivka disposal site. Up to the present day it's pretty radioactive. Another German robot called MF3 was more lucky. You can actually see a half of that robot in the town of Chernobyl at the mentioned exhibition. Originally it looked, however, this way. This robot was designed originally for the atomic industry and was not as heavy as Joker. So MF3 operated in the Zone J, but although it didn't have the Joker's sad fate, it was considered not very effective because it had a cable of just 100 meters, preventing the operator from getting any unwanted exposure. Finally, in August 1986, they were deployed one of the most effective robotic complexes, STR-1, that started to work from the Zone K. The main developer was Alexander Kemudjan, an Armenian scientist who previously created a series of Soviet lunar landers, the Lunokhod. STR-1 has pretty much common with its space brother, because the entire robot was completely made from titanium to reduce its weight. It also had 6 independent motorized wheels and a suspension system pretty similar to Lunokhod. Most failures happened in the television system. That system included two guidance cameras and one KTP63 camera that could turn around and also look on the EMD21 dosimeter mounted in front. By the way, in our previous videos we reviewed exactly those types of cameras, so do not forget to check it later. It's really interesting. Except for one cable-controlled modification, most STR-1 robots were radio-controlled and powered by rechargeable zinc-silver batteries. For recharging, special stations have been deployed on the roof. All this significantly increased the mobility of the robot. This radio control system of STR-1 was one more project of Mr. Koshmekov in Chernobyl. So he showed us a never-used receiver system of it. It was a spare set that he saved back then. Now you can also see it at the Museum of Chernobyl in Kiev. The control panels were somewhat similar to those on the T180 bulldozer, and many years ago it was still possible to find remains of STR-1 panels at the Jupiter plant in Pripyat. Initially, STR-1 robots were brought to and removed from the Zone K using a German Liebherr crane installed behind Unit 3, here. At some point, that crane accidentally got broken, so they were forced to use helicopters to transport them. STR-1 have been pushing graphite and other debris down to the Zone V. In this way, levels at the Zone K were reduced nearly 4 times. Then, when the job there was over, two of such robots continued pushing it further from the Zone V down to pre-installed containers that later were buried near the end of the turbine hall of Unit 4. A few remains of STR-1 are standing near Joker in Burakivka disposal site. One more you can see at the exhibition in Chernobyl town. In August 1986, Institute of Robotics and Technical Cybernetics deployed to the zone heavy bulldozer robots of own design called TR-G1 and TR-G2. At first it looked like designers finally learned from their mistakes and eventually moved all electronics to a remote control post, and what was not possible to move was changed to reliable relays. However, those, same as later machines made by this institute, again appeared to have a fundamentally poor design. One of those robots that became non-functional on the roof eventually had to be thrown inside the reactor opening. The next attempt was TR-B1, which had a gas-powered generator and a radio control. It was also not so effective, but interesting that remains of this very robot is still possible to find at outskirts of city of Pripyat. Well, they are still pretty contaminated. Perhaps one of the relatively effective machines created by the institute were two bulldozers nicknamed Vovochka and Antoshka, which were a modernized version of TR-G2. Those operated in the turbine hall of the Unit 4, but even that didn't change the terrible statistics. Managing, saving and servicing of the robots made by the institute ended up to 20,000 man-hours on site. The use of those machines was eventually discontinued. The rubble collected in that turbine hall was grabbed by those two large Forestri manipulators you can see in the Chernobyl at permanent exhibition. They came from Finland and they were hydraulic, very powerful, so they required a lot of skills to operate. There is even a footage of their testing. At the same time, they could lift up to 1.5 tons of rubble, which was a major advantage. Forestry were loading the materials into this cable-controlled transport robot nicknamed a dump truck. It was developed by Spetsatom and it was used to move the containers with debris out of highly contaminated zones. Next, those containers were transported to Pidlisny radioactive waste repository. I might be wrong, but likely this metal fragment laying in Pripyat is a remain of the dump truck. Next to Forestry in Chernobyl you can see one of most successful robots ever. This one, a cable-controlled Mobot-Ch-Hv, we shortly mentioned in our previous video. The first generation of it was deployed to the Zone N and could clean 2 tons of graphite, which is pretty much. Unfortunately, when there appeared a need to move it away with a helicopter for repair, a lock suddenly opened and the robot fell from nearly 250 meters and just burst into pieces. So instead, two robots of the second improved generation were quickly created. Those made a massive amount of work in the zones N&M, cleanup of remaining debris, radiation surveys and even a blasting and removing a highly contaminated pipe, which was never done before using only a remote control mechanism. One of Mobots was in use in the zone up to mid-90s and now you can see it in Chernobyl. The original deployment cards for Mobots, however, are in Pripyat, next to the infamous claw. Besides other types of equipment, Mr. Bukov mentioned one more Liebherr crane that they operated since 1988. It was equipped with remote control systems and a technical television, all mounted inside a separate special command truck. But even more interesting is that this Liebherr crane had a special slinger robot that would attach a cargo to the crane remotely. This crane was really effective and moreover it still exists and is operated in Chernobyl. At the beginning of the 90s, the tasks have changed. There appeared a need for new, totally different types of Chernobyl robots, the machines that could explore the shelter object and manipulate the materials inside. The thing is, the shelter, or sarcophagus, as it is also called, is a temporary structure and one day it has to be removed, and the materials inside have to be confined and buried. But before, the robots were needed to actually study the shelter, because the conditions inside the sarcophagus differ very much from place to place. Some rooms are blocked and people can't get there. Some rooms contain fuel-containing masses, also known as fissiliums, that consist of radioactive ceramic-like substances. Those unique formations are especially interesting because they tend to change their features over the time. So we are sure you heard about so-called elephant foot in the room 217/2. It's often considered the most radioactive object in the shelter, however in reality it is one of many comparable. To be accurate, originally the term foot even was used in a plural. So when it was discovered, it emitted around 8,000 roentgens per hour, and since then the level dropped enough that making of this picture became possible. But less known fact is that in June 1998 it started to crack and surface turned to dust. In 2021 it started to look like a heap of sand. Write us in the comments if you didn't know that. This was just one of multiple examples, so all in all there appeared a need in entirely different class of machines that could help to study process as this. And Spetsatom, later already transformed into a state emergency technical center, continued research work on the new robots for the disaster zone. Perhaps one of the biggest projects was a joint collaboration between the center, the Chornobyl Nuclear Power Plant and the Pivdenne design office. So, since 1994, they developed a very interesting modular chassis. That could be turned into 11 different machines of all kinds of manipulations with radioactive materials, such as scouting, drilling, mechanical cutting, pressurized destruction, vacuum dust removal, water pumping, loading, transporting, bulldozing, and last was repeater. It provided the communication and data exchange between the units that operated all together. Due to many reasons, in 1996, State Emergency Technical Center, former Spetsatom, ceased its operation, but up to the present day, at the abandoned offices at the Jupiter plant in Pripyat, it's still possible to find sketches of their never-built robots. But the work was not abandoned. The mentioned modular system transitioned to the Interdisciplinary Scientific Technical Center shelter of the Academy of Sciences of Ukraine. In 1992, the shelter center develops Tier 4, one of the first robots that could drill and retrieve samples from the fuel-containing masses. Later appeared Tier 5, which could make drilling, cutting and other manipulations. Returning to the infamous elephant foot for a moment, The natural degradation of the FCM resulted in the production of a very dangerous dust and small dispersion radioactive aerosols. There were a few technologies created to fight this dangerous dust, and one of them was using of special polymers. So in 1996, a special Tier 7 robot was created designed to distribute a special polymer compound over the FCMs in order to secure them and prevent dust spreading. So that's what it looks like. Perhaps one of the most unusual mechanisms created by Institute was this. This is a magnetic crawler that had wheels made of magnet, so it could slowly move on vertical metal surfaces. So its purpose was to measure levels of radiation on the northern panels of the cascade wall called hockey sticks. In 2004, the Institute created Tier 11, a robot for the fragmentation of highly active fuel-containing masses. It was equipped with a grabber and a water gun. In 2011, they created a multifunctional robot named DKVL. Its purpose is the extraction and localization of the FCMs from the chaotic accumulations of radioactive materials inside the shelter. In this photo, you can see it undergoing testing on its test site. What you have seen are historical creations, but this work is ongoing and newer, more sophisticated solutions are being created. So please let us know in the comments if you would like to learn about them in our future videos. And for those who want much more, join us on Patreon, where you can get unique Chernobyl insights, translation of unique documents, and various archive data. And that's all for today. See you next time.